Heat transfer is a core process in the study of mechanical engineering. It is the movement of heat or energy across different objects or substances. This report will show the differences between the theoretical and experimental solutions to heat transfer problems found in a real-world application. As the world advances in technology, it is common thought that most households in the United States have at least one television in their living room. A good percentage of families have more than just a television in the living room. They may even have some type of gaming system, such as a computer, Xbox, PlayStation, or even a Nintendo Switch. While having one of these gaming systems is fascinating and gives a new aspect of entertainment to life, they also produce heat. When one of these gaming systems is in use, you also have the television running to display the gaming system. With both the television and the gaming system on, the temperature of a room can change. Add a window to the room on a sunny day, and the temperature of the room can change a noticeable amount. Our goal is to find how much heat loss a window and different electronic devices have in a room. Our heat sources are a window, a plasma television, a computer, an Xbox One, a PlayStation 4, and a Nintendo Switch. We will be using thermal circuits to find the thermal resistance and then use thermal resistance to find the heat loss. Some assumptions we'll be making are the television and the window are both made of glass, the computer case is made of 1% carbon steel, the Xbox, PlayStation, and Switch are made of ABS or acrylonitrile butadiene styrene, that all the gaming systems are first-year products, meaning there's no changing to the system setup in later reproductions, and the heat coefficient H is going to be 10 watts per meter Kelvin. The conduction thermal resistance is thickness divided by thermal conductivity times the area. The convection thermal resistance is 1 divided by the heat coefficient times the area. And the radiation thermal resistance is 1 divided by the radiational heat coefficient times the area. The total thermal resistance is equal to the conduction thermal resistance plus the convection thermal resistance plus the radiation thermal resistance plus the conduction thermal resistance. Once the total thermal resistance is found, we plug it into the heat loss formula, which is heat loss equals the temperature at the surface minus the ambient room temperature divided by the total thermal resistance. Here are some numbers we'll be using in our formulas. Thermal resistance is calculated in watts per meter squared Kelvin. The resistance for a window is 211.64. For the television, it's 408.28. For the computer is 49.55. For the PlayStation 4 is 3,857.1. For the Xbox One is 2,290.74. For the Nintendo Switch is 215.44. Here are the calculations of the thermal resistance totaled up, giving us the total thermal resistance in the right column, which we take the numbers given to us there and plug them into the heat loss formula, and these are the values of the total heat loss for the window, the television, the computer, the Xbox, the PlayStation, and the Switch. In the results, it is the glass window has the highest heat loss. The highest electronic heat loss is the television. Thank you.